Thanks so much, David.
Hello. Hi. Good to see you.
Thanks.
Water. Okay, thanks.
I'd like to thank David and Simone for putting together such an outstanding panel. The people in front of you have a lot of really interesting thoughts and are doing some fantastic work that has to do with bringing software intelligence into the physical world. The lines between real and virtual are becoming blurred, and I think we'll see them get even more blurred over the next few years as the sort of work that the panelists are doing gets extended and made commonplace. To my left here, we have Carlos Dominguez, who is from Cisco, then Dmitry Grishin, who's the head of Mail.ru and also has an investment firm called Grishin Robotics, Alex Hawkinson, who runs SmartThings, and Bill Rue from General Electric. So I'll have each of you say a few words about what you do, and as you do, also answer the question, why now?
I'm Carlos Dominguez with Cisco, as John mentioned, and I get to come to a lot of conferences and talk, so I do that primarily. Why now? I think it's a perfect storm, John, of a convergence of a lot of things. Number one is the processing power is available, the pricing is available now, and I also believe that the networks are there to be able to start supporting some of the connections. We work through a lot of the protocol issues. So, you know, we're starting to see the evolution of these things, and still with a lot of deterministic things that we need to tackle, but, you know, everything's available. It's a perfect storm.
Yeah. So the groundwork's been laid.
Yeah, groundwork's laid, and now it's taken it to the next level.
Awesome. Dmitry.
Yeah, I'm Dmitry. I'm one of the founders of Mail.ru, it's the biggest Russian internet company, which are now public. And also 1 year ago, I launched investment company Grishin Robotics, where I plan to invest $25 million to consumer robotics companies and Internet of Things. And why now? I think I agree with Carlos, it's prices going significantly down. And I think key reason for this is smartphone revolution, because most of the components which you have right now in smartphone, I also use it for Internet of Things and for robotics companies. So like you can buy right now HD camera for $3. And 10 years ago, its camera cost, I don't know how much, $10,000. So prices is going down significantly. The second important thing is that introducing of technology like 3D printers allow to do prototyping much quicker. And I think especially for hardware companies, prototyping it's part of the job which are really tough and very long. And right now with 3D printers you can do much quicker iterations. And of course to creating platforms like Kickstarter, which helps companies and startups to enter, especially for hardware, raise funding, but I think it's more important to understand what people think and how people react on your products and make some like market evaluation. So I think these three key components make me believe that for last 2 decades we make huge revolution in software in internet, and next 2 decades it will be huge revolution in hardware when we'll use all power of internet and extend it to real world, which my feeling have not too much innovation for last several decades, and we need to change it.
Yeah. You were telling me yesterday that adding something like a sensor to something that's never had a sensor on it is just a matter of a couple of dollars, right?
Yeah, you're right. For example, if you can look on this room, we can put a sensor to each chair, which will give the information, is person sitting on the chair or not. And for example, you can give real-time information how many people here in this room, how much power you condition or not, and change to understand.
So Alex, to bring and your home, regular consumers, and sort of put your home in the palm. So notable for a few different reasons, you know, trying to make it very easy and accessible, and also we're an open platform. So you know, some number of thousands of developers and device makers are building new interconnected things that work with us and what we're doing. You know, I think I'd agree with all the the other comments on underlying trends that are supporting it. I think the number one factor in why this is happening now, though, is the smartphone revolution, is my own hypothesis. I think that even with the underlying enabling technologies, really it's a psychology change in consumers and just in humans, where you expect the world to be hyper-connected and with you at all points. And of course, the underlying benefits of connecting up the physical world, as Dmitry was beginning to say, are profound and low cost and work because of the wireless networking technologies and so on. But it's just the hyper-connected consumer is sort of demanding it now.
And you're building a lot of modules that people can put together with kind of moderate expertise, right?
Yeah, so we've tried to make it easy for anybody with a smartphone. So we sort of jokingly internally say sort of $200 in 10 minutes is what you need to begin bringing your everyday things in your home online, like your front door, let's say. And then once they're connected, with simple applications, you can really change life to make it more secure, safer, more fun and smart in different ways.
Excellent. Bill.
So I'm Bill Rue. I'm responsible for GE's Global Software Center. I think at the core of GE, we make our money and are known for large machines like gas turbines, wind turbines, jet aircraft engines, CT scanners, and we sell the products and services around that. Well, what we see happening is everything that's been talked about: low-cost sensors, low-cost communications. In fact, we look at the consumer internet, and that has just driven such change that we think now the technology prices are such a point we can drive it into the industrial world. So we're really, where Alex talks about the hyper-connected consumer, we think about the hyper-connected a plant or the hyper-connected machine, and we see how is that going to change our world. And when we look at our opportunity versus the consumer, I saw a Bank of America report recently that said about $32 trillion a year is spent in the operations in the industrial businesses we serve. So we look at the idea if we could make a 1% change just in that, it's a huge opportunity for us and for others to participate and change the industrial world the way the consumer world has changed.
We've seen, a lot of people have noticed that software is a terrific business to be in. Does this mean that GE is getting out of the industrial business and switching into the software business?
We get this question all the time, and I think the way our chairman, CEO, Jeff Immelt says, he's come to the realization that every business has to embrace software and analytics in a way that they haven't before. They have to make it a core competency. However, that doesn't mean you're a software business. And I think, to me, the greatest software business in the world don't sell software. I think of Google and advertising and Amazon with retail and so on. Mm-hmm. So what we see is not so much the idea that we're a software business, but we realize that our services business, and by the way, I think this is all services businesses, are going to be foundationally changed through this idea of sensors, data, analytics, and how we enable people to be more productive. So for us, the cornerstone is really not being a software company, but extending our services to go to software-enabled services, and we think that you have to make it a core competency.
Mm-hmm. One sort of comment for this audience is that I think this is very natural at some level. I think of this as sort of the third phase of the internet. You had 15 years ago, sort of information started to come online. It predated sort of Google. And now the knowledge graph is there. What is the impact of that on society, from how you discover answers to problems to finding businesses that you want to intersect with? And it's just changed so much. And of course, offshoots of that is the cash flows changing the software landscape as well. But then people are online, and you have the social graph. And what does that mean for elections, as an example, the topic just before this? And now what's the next thing to be engulfed by the internet? There's the information, there's the people, and now it's the things. And the physical graph has equal implications, if not more profound ones, about digitization and software and what it's going to do to the everyday world.
The powerful thing, Alex, I agree with you. I have a very good friend, Rick Smolin, who wrote a book. And what he said as he was describing the fact that things are connecting, they're all generating data, and we're gaining insight. And he was trying to describe the benefits of that to like a 10-year-old child. And what he said was, and I love this description, he says, imagine if all of us, we were walking through the world with one eye open. Mm-hmm. That's the way we all see the world. And all of a sudden, something's going to come to us that's going to give us some insight or wisdom that for the first time, all of us are going to be able to see the world with two eyes.
Yeah.
And when you think about what this Internet of Everything, Internet of Things, the industrial internet, or whatever we want to call it, the fact that things are connecting, they're sensing stuff, they're generating data, that data is being processed, it's, analysis are being done, and whoever is the recipient of that is going to have some knowledge or insight
Yeah.
that they didn't have before and ultimately change an outcome. That's why this thing is the here and the now.
Absolutely. The way that I've often thought of this is as, you think of something like Amazon.com and how heavily instrumented Amazon.com's website is and how much value they get from that instrumentation and how much intelligence they can use to guide their business. And you take that sort of instrumentation and intelligence and apply it to the physical world instead. And you get a similar kind of intelligence out of it, similar kind of ability to make really good decisions.
Maybe some practical examples might be helpful for people, but it's also happening because the benefits, the intersection of the technology point is that the benefits far outweigh the sort of the cost of doing it now at this moment, from friction and the economic cost and so on. But it's not just, it sort of starts with, there's individual problems that it adds value in the consumer space, and you can give great industrial, but you mentioned kids as an example. I mean, 2 kids die in the US every day, toddlers that consume household chemicals that they shouldn't have, right? And a tiny sensor on the cabinet can make a huge difference in the lives of the $300 that go to the emergency room every day and so on as well. And so these little life problems can be profoundly impacted with a free solution effectively, but then you magnify it up and you say, okay, well, what about turning things off automatically? You mentioned the air conditioning in this room when people aren't present. In households, that's 30% of energy use can be impacted by lighting appliances, basic HVAC system, just by invisibly making it operate better when you're not there, not impacting the way you feel about it in the near term. So these changes, and I could go through security, safety, insurance, crime, health, other stuff. They're really profound in so many facets of life that's the sort of Cambrian explosion we're about to see. Is the enablement of all those benefits.
And if looking forward, I just thinking about where we can go in this direction. And my vision is that we'll have 2 stages. First stage, where we right now, we start to censoring the physical world. So sensors will be everywhere. You can make video, you can get some sensory information of temperature, anything. And we will collect this data and understand this and try to make some application based on this data. Mm-hmm. And of course, the number of sensors and places where we can put it is growing exponentially. But I think much more exciting for me, like next stage, when you can not only censoring the world, you can change the world. Mm-hmm. So it means you have not only understand if somebody is sitting on the chair, you can move this chair, right? So you really can change physical things, and this is direction I think is just create absolutely new amount of application which it's very difficult to imagine right now, and I'm really excited when you can apply all this power to changing physical world. And the other thing which I want to mention, I think that for pretty much for all entrepreneurs, it's very obvious that you can go and start internet company right now. Like you can have 3 of your friends or co-founders and start software or internet company. Yeah. But it's not very obvious that you can go and start hardware or robotics company, which are now is really situation. You can have 3-5 people, have 100,000 initial funding, yeah. And with a lot of building blocks, a lot of this hardware available, I think we will have big new wave of hardware startup, and I hope it will be bigger and bigger. And my belief, the biggest innovation will come not from big companies, it will come from new startups which will try to leverage this new Internet of Things tendency.
But one of the core tenets of this discussion is that it is getting easier and easier to start building hardware. I mean, the prototyping tools are available, the Chinese supply chain is available, even the highly automated American supply chain is coming back and is really competitive again for developing things in small runs and starting to develop new products. I want to hear Alex and Bill both comment on what sort of expertise do you need to start building hardware and intelligent physical devices. You come from very different backgrounds on this.
So, we break the world in the consumer and the industrial world. And, I think the enabling technologies are much the same. And by the way, we see the idea of free, open source hardware and software as sort of, and the cost of things coming down as the enablers. But the real value is in the applications that you build on it, and not the technology. Technology is interesting, but just the enabler. When we look at the industrial, we see a lot of people building applications in the consumer world. I'd say, everybody has an experience there. Everybody has domain knowledge, so anybody can get into it. But when you look in the industrial side, what's been, I think, the key barrier is that domain knowledge about how an industrial power plant works, or a jet aircraft engine, and the regulatory environment creates a domain knowledge that's much more, much more barrier that fewer people have. So we think that in the industrial side of things, the technology is an enabler, but it's nowhere near enough. The domain knowledge and those who have that domain knowledge are going to be at the center point of driving those things. Because in the end, there's really two things customers want in this. One is almost all of them are driven by fuel and carbon. If I can reduce fuel consumption and carbon, it's almost always the number one and number two cost in these industries. And number two is if I can stop things from breaking, and we all know what it's like to have a flight canceled, and about 41% of all cancellations are mechanical. If I can get rid of that in these industries, that's huge. But you really have to understand the domain, understand the physics, understand the operations. So we think the barrier to entry in the industrial side to domain knowledge is huge, where the barrier on the consumer side is a much lower bar. But the technology for both of us, I think, is pretty much the same enablers.
Yeah.
I mean, I wake up some mornings. So the idea for SmartThings was over Christmas of 2011. So it's 22 months ago or something. And I was totally a cloud software guy before that. What the hell? How did I get here? The reality, a lot of mature networking standards to add connectivity. If you go into one of these plants and you haven't been, you realize the rise of the machines, like lasering the pieces together and stuff, and you're just like, wow, you load in your CAD design and out pops your prototype device. And 3D printing and things like that to get the enclosures right. So we actually did all of our first 10,000 households, all the manufacturing in Michigan in the US, because for agilely moving through the process, it was so quick to iterate our various hardware components from our hub to our devices. We had to find some domain expertise. We had our own secret methodology for going and recruiting some electrical engineers into the business that were great. But from start of looking at it as sort of a technology person to having our first working prototypes, 4 to 5 months. Certified within 10 months and shipping within 12 months or so. And these are pretty sophisticated things at some level. What we realized, though, is that the hardware is just such a thin layer. It's sort of the enabler of the software opportunity from our standpoint. So we enable it to further break down the barriers to it's going to accelerate other hardware projects that don't need to build as many pieces that we did. And of course, developers that can use their regular developer skill sets to build apps for the physical world now that we've created this underlying enabler. So, I don't know, there's a GE device, there's a light switch. We've given every GE light switch an API, right? And who knew that Double Tap was an app that the developer ecosystem would write that when you double tap your light switch, it actually means something different. And you can configure in your household so that when you double tap your master bedroom light switch at night, it means you're going to bed and it locks the doors and shuts off the lights. So it opens up the physical. It's just both easier to build hardware, but then there's just an avalanche of developers that are just now getting access to this opportunity space that they haven't been able to go after before. So
Right.
think of your that app marketplace. There's an app for everything on your mobile phone. There's chaos to sort of be sorted out, but that sort of same explosion is coming to the physical.
I'd say, though, and for the lighting world, I think you want to open up. There's certain kind of applications. You don't want to have someone double tap their gas turbine, and suddenly you find it gets shut off. We had a very interesting security discussion that dealt with certificates and things like that. And if you don't have a certificate, you would, the way it works in the consumer world, you would turn off that device. Well, you really don't want to turn off your gas turbine. As people don't get that testy when their connectivity or they have to reboot their machine. They get really testy when their electricity runs out at their house. So there's a different kind of world. However, the technology is the same. And the question is, how are we going to apply it in that world so we don't end up with unintended consequences? Very different in an industrial and consumer setting.
Right.
I wish I had a picture to show you. So a 10-year-old wrote to us last week, and we were posting it on our blog in a couple of days. At an Inventors Fair, used an Arduino Shield that we've built one that works with our platform and hooked up a set of laundry applications because he was tired of his mom sort of reminding him to, do his stuff, and whipped it up in literally over the course of a week and has a functioning prototype of the ecosystem. And so again, the barriers are lightweight. There's certain low-hanging fruit problems you can go after very easily, and then there's clearly, control theory and on up exists for a reason, in large-scale industrial processes.
Dmitry, you're an investor in a company that runs satellites with Android.
Right, and I think Peter may be somewhere here, he'll be presenting, so it's better for him to talk about his company. But yeah, I think we did several investments, and one of this is like satellite company which use standard called CubeSat satellites, and the idea for the company is to build huge cheaply and give access to them to students. And I think talking to what Alex said, I hardware device to the market, what we see and talking with startups, it's still a huge issue for them to work with hardware stuff. And if you look on the Kickstarter, a lot of Kickstarter campaigns later have problem to deliver products on time. Yeah, it's still a huge issue. People educated, and I think one of the important things which we are trying to do, we think we need to build ecosystem of people who understand engineering and manufacturing. And right now, these people are sitting in big companies, and this knowledge is not very, very accessible to big startup community, but situation is changing. For example, we see that more and more like hardware incubators start to be set up. We are invested in one of them called Bolt, which are based in Boston, and these people, it's like special place where you have machines, you have engineers who have experience of building the product and making manufacturing, and of course they can help you to not make a lot of stupid mistakes. But still, as people joking, hardware called for the hardware for the reason because it's hard. We're exciting that more and more internet people, let's call this, coming to hardware world, and they bring a lot of internet culture to more understanding consumer, to quick iterations, but still they found they need to deliver their physical items to the consumers, right? They need to work with the surprise and say, this size of the package is not working, you need this size. Otherwise economics is not working. For them, for a lot of them, and initially if they're writing business plan and say, okay, we have 20% margin, and it's good, but the final price can be taken by retailers. And also, I think huge thing which we see very often with hardware companies that usually when you deliver to the customers, and if you see problems, you have some problems, people send you this hardware back. And you need to do with support, understanding how to dealing with this. This is, I think, we see this over and over, and hardware startups now educating themselves, but definitely it's people.
Yeah.
And also very important to have several ways. You have a successful startup, and then they can teach and be advisors from internet and learn a lot, and then.
Yeah, one of the key points we're putting together, which is called Solid, is still incredibly. These challenges.
Yeah, you're absolutely right.
Challenges, incredibly scalable, return on into hardware in the same ways that you're used to.
And I think in terms of hardware, we need to build a lot of building blocks. We already have Arduino, Raspberry Pi, a lot of other things, but still it's much more. Building blocks will be much easier to set up any kind of hardware device.
I mentioned Kickstarter a couple times. We had a big Kickstarter for us. I mean, we luckily had capital in to make it work. Based on Kickstarter, just the $1 million, right?
Wow.
And so we just announced our A round actually this morning, economic support for the company with Greylock leading. But the barriers. So the barrier is not nothing, of course, and the risks are you only get a couple. It's got a fundamental problem, you're done,
Right.
Unless you're a giant company. But it's the zone where, in the active startup and investor winners out of it.
Now, I want to raise a point that Dmitry made earlier when you said, and not from the big companies. So I want to hear Carlos and Bill respond to this. Both of you are making and taking innovative approaches to some of the problems of sort of software. Are you building the right sort of innovation structures?
You want to go? It's kind of interesting. I know the work that Dmitry and Alex and others are doing is actually happen everywhere. But when you look at it through the lens of a couple little different things, world that there are billions of devices connected, of technologies, and being very easy to reproduce, there's going to be trillions of. It's not a minute task. A function growth issue. So how do they connect? How do we authenticate it? That you say who you are. There's a manufacturer that makes light post LED work on the top. It's got these biological sensors, water sensors, temperature, and all the things that you want. It's got LED. This is deployed in a city during some sort of going on. Somebody hacks into the light and one of the LED displays, biological agent detected, emergency side, say run this way. You can actually harm a lot of people just hacking into other issues So from our lens and our point of view is making sure that they are what they say they are. Things behind it really makes a big difference. The second thing is everything. There's a new wave. I mean, when we shipped out somewhere and being stored and processed in the cloud and all that other stuff, there's a whole new wave of data in motion, which is these sensors, and because of the processing power and everything else, things are occurring on a local basis. For example, back to the lighting. If I'm walking around, the lights are going on as I'm walking. If it's going back to the cloud to some sort of central site to turn it on, it may not make it in time for me to do there. So you want to basically make sure that you're activating and processing and bringing some insight and knowledge at a local level. But you also want to take that and combine it with some historical stuff to give you the best outcome. So we're worried about the security, worried about how to connect everything because this is going to put a tremendous amount of burden on the network, and how do you do it efficiently?
So security and robustness.
Robustness,
yeah.
and then mixing it with the analytics process. Sometimes you need to reconfigure. I mean, you're in a stadium. Just an example, you're watching the World Cup. Somebody scores a goal. If you look at the peak of what's happening on the network at that moment in time, everybody's doing a video. If you're a service provider, the demands that are coming to you are incredible. So how do you do it if you're doing it on a manual basis? You can't. So we're looking at it for those peak events to have enough intelligence on the network with automation and some controls and business rules to be able to reconfigure things, in an on-demand basis.
Right.
Maybe get more servers and open up more storage, open up more bandwidth, and that's kind of how we're thinking about it.
Bill, how are you approaching this problem of innovation inside a big company?
Look, I think that's mostly true in the consumer side. There's a very low barrier of entry here. Failure and pivoting and fail fast. I mean, you can do that in a consumer world, and everybody has that knowledge. Now, on the industrial side, it's quite different. I mean, fail fast pivoting in jet aircraft engine business is not really going to happen. At least I believe in my lifetime. I think that the technology and complexity, the regulatory environments, and so on. And by the way, simple thing like the law of physics has a lot to do with what you can and can't do. So the fact is, I think that's going to continue to be the domain of big companies who have that kind of skill set. Now, where innovation is going to occur is around that operational number, because when I talk about the size of the opportunity in the industrial world in operations, it dwarfs that consumer side. But the problem is, how do we innovate around that to improve? So can I get insight into how I operate the jet aircraft engine so that I can reduce fuel burn, the number one cost for an airline? That's tremendous opportunity. Can I figure out how to reduce and get rid of that unscheduled downtime? I think that's where big companies and small companies will play. But if you're really going to get into this idea of a gas turbine and a power plant and generating electricity, if you don't have some domain knowledge, some way to connect in to understand the physics, it's very hard to get in. So I think the reality is we're going to see that companies like GE in the industrial space have to embrace innovation and help to drive it. At the same time, I'll tell you, we're investing into small companies who are innovating. So, we invested in a company called Mana, and it does search, but for the industrial space. So I think because the idea of search and how you could apply that to people in the field in a way that it supports their job, where they find the right person, the right knowledge. I mean, we've talked about that for how many years? I think we're just at the cusp of getting there. So to me, the industrial space is a little more complicated than the consumer space. It's going to require partnerships between the big and the small. It's going to require leadership, because in the end, the one thing that happens is people get real testy. When the plane doesn't fly, when the electricity goes off, how many people really are okay with a couple of days without electricity?
Yeah.
It's a totally different environment you deal with. So when you think about it, I think a partnership is more important here, and as a result, this is going to go a little slower, but I think that's how it'll play out.
There's actually kind of an interesting, dichotomy. On one end, you've got, an aircraft engine, and the other end, we've got, these sensors in the home. And where I think the real value is going to happen is when we kind of meet in the middle and converge. We just came back from an event in Barcelona that we sponsored to try to bring like 700 different companies together to talk about standards and data exchange and a few other things. And one of the examples they showed was they had these sensors that the Barcelonians were putting on their windows that detected air pollution, temperature, and a variety of other things. And the example that was shown is the actual city of Barcelona was bringing it all in, monitoring pollution, and then from there, they were driving some gamification programs down to the users to say, hey, we'll give you a bonus if you ride your bike today, or we'll give you a bonus if you ride share, or take this bus, and you'll get some things. So, it was kind of interesting of the power of looking at these silos all of a sudden being converged, both from an industrial and government side and from the user side.
Dynamically priced air pollution.
Yeah. And then the third layer of that, which was quite interesting, if you took the third view, which is the enterprise account, if there's they saw in this graph that there was going to be a demand on power because of the temperature, and what they wanted to do was actually put incentives out to the enterprise accounts to shut power down.
Yeah.
Shut lights off, shut things down. So, you're starting to see this, where the power really lies is not, this or that, it's really the convergence of both.
To me, the power in this is that it's modular. So you can have GE operate the gas turbine very reliably, supply some data about output in the turbine that goes into the power company, which is an industrial firm and very robust and very sophisticated, then supplies data on electricity pricing to any module that can accept data on electricity pricing and do intelligent things with it. I think that's what...
No doubt. I mean, one comment generalized across the space is that even in the consumer side, I think the companies that win will take things like the security, privacy, control theory underlying pieces that you need to get right very seriously. Yeah. So us as an example, even though we're a little startup, 40 engineers, we do ethical hacking audits on the outside on the platform every single month. We've watched with great interest the Belkin Wemo Hackaday post that started a fire in a home by turning something on and off too rapidly that wasn't on our platform, but realizing that it's not even always nefarious. There can be two apps, they're competing to turn something on and off, let's say as an example, and you have to build into the platform level that not happening, right? And so, back to Dimitri's point and your point on modular, we viewed it as the role of some of the early companies, smart things on the consumer side, to try to put in place some of those things so that it frees up innovation by others. So they're not having to, the app developer shouldn't have to know that about the device that's being touched by their application.
Right. Now, Dimitri has a comment.
Yeah, and let me not agree with William. Okay. I think industrial market need much more innovation, much more competition. And I think right now, biggest company do not have too much motivation to try to make disruption technology. For example, if you look on car industry, people do very minor improvements until Tesla coming to the market, and then they try to moving quicker. And I think that we still do not have supersonic jets only because of this, right? We should have much more competition in the industrial world. And if you can look on internet, we already see more and more consumer products coming to enterprise. And I hope the same situation will happen with hardware. The most thing we involved in creating consumer market, we will try to bring it to big industrial application, maybe as building blocks, maybe something else. But I fundamentally believe that we need much more competition in big industrial companies. And until now, they don't have too much motivation to make huge bets. They improve engine by engine. So we fly at maybe 800 kilometers per hour, now 85, 86. But to make huge bets, we need much bigger competition.
So I'm sorry to cut the conversation off right here. We only have a few minutes left, and we have to definitely want to take questions from the audience. Over here, we have a couple of questions.
Hi, Joan Cycler with Dell. In one of our scenario game playing routines, we took the industrial internet, we took the advances that were taking place in material science,
Yeah.
we took this real shift from ownership to rents that are going on. Theoretically, GE is approaching the point where you could build an engine that literally would last forever with all of the sensors and everything that's associated with it, or a locomotive, or any of a number of things. Ford could build a car that could last forever because you're monitoring everything and predictive analytics telling you repair it before it fails. That totally disrupts manufacturing business models and has a significant impact on employment, both in manufacturing and repair and maintenance. So I was wondering if the panel could kind of talk about those sorts of implications, even though everything's going to be better, we all know that, but there's some real implications there.
So, just a couple things to note, and with regard to that. First of all, if you just take jet aircraft engines, it takes years to build one, right? So it turns out that our engines last decades. In fact, we sign service contracts to service them for decades. And we could continue to service those over longer periods of time. What is changing, however, the airframes change, right? Size, scope, and you have to adjust, obviously, the jet aircraft engines. The second thing is innovation is occurring in these markets continuously. If you could, you'd innovate every few years like you do in the chip market and others. It's just, the scale and the time frames of these are longer. So over time, the ability to put new materials, and materials science, supply chains, everything are changing to the point where it is much more cost effective to change those out in 2 decades than it is to try to keep something forever, just because you are able to do things with the physics you couldn't do before. So today, these machines run for a very long time. In the utility domain, we have products that have been out there 80 to 100 years in the field that are still running. So the fact is that what does change is the materials, the physics, the designs, the need to deal with other kinds of environmental factors, and you're always going to have innovation on these. So I think, today many of these products are living for a very, very long time.
Alex,
One quick comment on that, that I think is in the job space even more so than in the hardware universe. I think the implications of connecting up all this data have big implications for other industries. And I'll give you 2 quick examples. One is the insurance space, which is about risk mitigation. You can, mitigate a lot of risk, right, with perfect information sort of arising out of the world. I'll give one example, which I think that whole industry is ripe for disruption over the next 5 to 10 years. I think that another is, we heard from Aetna, the healthcare space, in a wonderful way, the implications of putting these sensors in place, and sort of as an example, in elder care scenarios where we already have lots of applications being built on our platform that improve the lives of people incrementally, very simply, but there's a big ecosystem implication of that as well.
Let's just take one more question very quickly. Yes, sir.
My name is Gaurav Dhillon. I'm with SnapLogic. So a question from a software plumber to the audience. What standards should we pay attention to in protocols? I mean, there's OBD2 in the car industry, but there's so much of this going on that for us to track it and help our customers use it, we have to pay attention to this. So just your thoughts on standards and protocols in this area.
Carlos, IP.
Well, IP. Actually, if you go to our
Internet
website,
protocol.
if you go to our website, there was a lot of standards discussion in Barcelona, and that's all being published. So you might want to see what the collective intelligence of about 700 people that are trying to do this market, what they're saying. But TCP/IP is a very foundational one.
So we see there's a lot of underlying competing standards. It's very fragmented now at the connectivity layer. So Wi-Fi, Zigbee, Z-Wave, and a bunch of others that are out there. There's not yet a set of standardization above the connectivity layer for applications, right, and common data types that come out of some of these physical connected things. We're trying to do some of that in our platform to make it easy, but it's it's one of the places you'll just have to see evolve a lot over the coming years. So just encourage you to just ping me if you'd like to talk about it more.
We think on the industrial side, there's plenty of standards and regulations, by the way, more than sometimes you can figure out how to deal with. I think you probably know that. At the same time, what we see is and we're working now to try to create some consortium to deal with the industrial side of this as effectively as the consumer side has already done. But the industry is a step behind. And as a result, I'd say you end up with more proprietary solutions, which don't lead to this building block approach, which we actually see as the big inhibitor to being able to move these industries forward. So the fact is, I think we're probably a decade behind where the consumer world is. On the other hand, I think it's a natural progression that the technology pricing had to come to a point where the industrial world could take advantage of it. And consumer world is still going to lead the way, and we're going to have to figure out how to evolve that and specialize it for the industrial world, but not do something different. And I think that's the challenge that's existed in this space. So I think you'll see some things in the next coming 12 months that would start to change that.
All right, I've let our conversation go well over time, but I know that we will continue this discussion over the course of the next day or two with all of you, and I'm looking forward to it. Thank you again to the panel. You guys are fantastic.
Thank you.
Great discussion. Really, really great. Thank you so much. Congratulations on the news today. That's very cool. Thanks, Dimitri.
David.
Really good. Really well moderated, too. Jordan Brandt last night announced that he was doing a 180 on his 180, so I have no idea what he's going to talk about, but he's going to do it next. So Jordan Brandt from Autodesk, please come up here and tell us whatever you were going to tell us on those chairs. Oh yeah, through those chairs. There you go.
Full 360 now.
360, okay, whatever.
Good morning, everyone. Yeah, so I mentioned last night that I changed direction. So I'm new at Techonomy, it's my first year. And I was inspired by Stuart's comment that makers are the new revolutionaries. So I decided to switch to a topic that was much more personal to me, something I can sink my teeth into. So it's interesting now that DIYers and folks from farming communities around the world now have this cool new moniker that they've unwittingly adopted. They're makers. So I know that space. Growing up in a farming community, I remember a friend of mine and I were out camping on his farm, middle of nowhere. And it was getting cold, and we said, wouldn't it be really cool if we had a hot tub right now? And we looked around, we had a horse tank, we had a PTO pump on a tractor, we had a 55-gallon drum, and we had a moonshine still. 2 hours later, a few swear words later, we had a functioning hot tub sitting on cinder blocks in the middle of nowhere. So then growing up, going to architecture school, everyone's designing and making things. Working at engineering firms, same thing. So by the time I got to graduate school, I did what any poor PhD student would do. I generalized from my really small sample set. Everybody's a maker. Fast forward a few years, small New York apartment, just got my new MakerBot, had it set up and humming in the corner, making something absolutely worthless. And I was sitting down to dinner with my girlfriend, a nice freshly delivered meal from Seamless, and I was pushing that shitty little plastic fork into my korma, and it was like bending and deflecting as I didn't think it should. I said, honey, wouldn't it be awesome if we could design and make our own silverware? And she looked at me with this like scowl of incredulity, saying, isn't that what people like you are supposed to do? And I realized that, even the educated and ambitious people don't really want to sit down and design and make all of their own things, but many of them have ideas. Talking to Connie last night, I had an idea to make bowls for her dishwasher that actually fit. So now the challenge and what we need to do, and can we get the image up on the screen? So the problem is that we all need to be makers. People in the situation in the Philippines don't have a choice. They have to be resourceful. So we need to enable them with the tools and the capabilities to make for themselves. And then hopefully they'll come back and teach us how to consume less and how to make and mend our own products. That's it. Thank you very much, guys.
Jordan, thank you.
Thank you, sir.
And within 180 also. That's very impressive. Come on out, Jim.